All right, this is the key for the exponential and log equation group work activity. We're starting here with a. 81 to the negative third equals 27 to the 3x minus 4. So when you see an exponential problem, you want to ask yourself the question, can I make the bases the same? So if you can make the bases the same, that's what you're going to do. Can we do that here? Yes. So 81 and 27 can both be written in base 3. So this is 3 to the 4th, all to the negative third. And this is 3 to the 3rd, all to the 3x minus 4. We're going to use the exponent rules to distribute those exponents. So we're going to get 3 to the negative 12 equals 3 to the 9x minus 12. Now I can set those equal to each other. 9x minus 12 equals negative 12, which means that 9x equals 0 or x equals 0. You can always go back, plug it in, make sure it works. All right, B, similar question. 9 and 1/3 can both be written as the same exponent, so we can write this as 3 squared, all to the 9x plus 21, and this as 3 to the negative 1, all to the negative 3x squared minus 3x. We can distribute, we'll get 3 to the 18x plus 42 equals 3 to the 3x squared plus 3x. I'm going to set those equal to each other, those exponents equal to each other, and I'll get 18x plus 42 equals 3x squared plus 3x. We'll set, this is a quadratic, we got to set equal to 0. So we're going to get 0 equals 3x squared minus 15x minus 42. I can take out a 3 out of this, so I can write it as 3x squared minus 5x minus 14. Two numbers that multiply to get negative 14 add to get negative 5 are going to be negative 7 and 2. So 3x minus 7, x plus 2. So my solutions are x equals 7 and x equals negative 2. Okay. So we're using the exponent, we're making the same base, we're applying the exponent rules, and then you just have a regular quadratic equation here, setting it equal to 0 and solving. Okay, are you guys good? Okay. All right, C here, so 2 and 99, this one's different because we cannot write these in the same base, so we're going to write them as log. So this is the equivalent of saying log base 2 of 99 equals x. So if you were not given a calculator, you could leave it in like this exact form. If you do have the calculator, you can plug this in, and you would get 6.63. Okay, over here, so we're going to do something similar here, but we've got to get the exponent alone. So we're going to subtract 1 from both sides. We'll get 6.1 equals 2 times 4 to the x plus 5. Divide by 2, divide by 2. We'll get 3.05 equals 4 to the x plus 5. And now I can rewrite this as a log, right? So we're going to say log base 4, 3.05 equals x plus 5. We're going to subtract 5 from both sides. So as an exact answer, it would be log 4, 3.05 minus 5 equals x. In the calculator, that would be here 3.05 minus 5 is
it's like negative 4.2, I think.
negative 4.2. Okay. All right, those are the exponentials. Let's take a look at the logs. So in the logs, unless they're the same log on, unless it's the same log on both sides, you need to isolate that log and get it alone. So here we're going to add 6 to both sides. We're going to get log base 4x equals negative 1. We're going to divide that by 3. We're going to get log base 4x equals negative 1/3. So we can write, now we write this as an exponential for the negative 1/3 equals x that is the same as 1 over the third root of 4. Okay? Here, so when we have like addition and subtraction with logs, we want to combine them. So we're going to combine the 9x and the 4 to be log 6 9x over 4. That's using that quotient rule, that quotient property. And then we can write 6 squared equals 9x over 4, and we're going to solve. So that's 36 times 4. So 144 equals 9x. So x equals 16. With the logs, remember that you do need to make sure that you don't have a domain problem. So we take a look here, 16 is good, and this is going to be good too, right? We have positive numbers going in for our input of the log. Okay, last two here. So this one is addition, so we don't divide, we multiply. So it would be log base 2, and then 15x equals 1. So therefore 2 to the 1 equals 15x, divided by 15, divided by 15. So 2 over 15 equals x. Okay, last one here. Log base 3, 2x squared minus 4x minus 7 equals 2. We have it already isolated, so we're going to write it as 3 squared equals 2x squared minus 4x minus 7, but we have a quadratic we need to solve here. So we're going to subtract 9 from both sides. So we're going to get 0 equals 2x squared minus 4x minus 16. I can factor out a 2. X squared minus 2x minus 8. 0 equals 2x minus 4x plus 2. So then solutions are x equals 4 and x equals negative 2. Be careful here that when we plug these back in, we're gonna get positive numbers as an input, so we're just going to double check that. So 4 squared times 2 minus 16 minus 7, so we're good here. And then negative 2 squared, so it's 4 to 8 plus 8 minus 7, we're good. So both of these are fine, but make sure you check for extraneous. Okay. All right, if you finish this, you should hop on the homework.